साजने ढूंढन मैं फिरूं, हेज कर जोगण रोवे सिरे।
Since 1950, the world's population has doubled and water use has tripled. By 2050, nearly half the global population will face water shortages.
There's definitely a global water crisis going on, and it's going to get worse. So as our population increases and as climate changes, we are going to see increasing pressures on water resources.
It's sad to think that there are women that spend the bulk of their day carrying water to their families. On top of that, it's very commonly polluted.
1.1 billion people have no access to potable water. The World Health Organization estimates that water-related diseases account for 80% of all sickness in the developing world, claiming 5 million lives each year.
We improve our capability to find and refine every other natural resource that we have. And we have not done that with water, but we can and we should.
While traditional approaches to water development have proved inadequate, EarthWater Global has a unique, proven, large-scale, and sustainable solution available today.
Of stress, so you've got recharge going into Central Asia and Southern Asia.
We've assembled a unique team of professional scientists, technologists, engineers, businessmen, financiers, and institutional leadership to go forward with this initiative to make discoveries on a worldwide basis of new major water resources.
Exactly. Could you explain the area that he's in?
EarthWater Global was created to bring low-cost, sustainable fresh water to governments at zero initial financial risk.
After decades of work in the oil and gas industry, EarthWater Global President Robert Bisson developed an innovative theory about freshwater supply.
The eureka moment was when I realized that the great rift systems of East Africa were leading to regional collection and transmission of water, not by a few miles, not just going outside a few local boundaries, but going hundreds or even thousands of miles all over these vast desert terrains of East Africa. And this was really a mega watershed phenomenon.
For millions of years, continents shifting across the surface of the planet have collided with incredible force. These tectonic collisions have shattered the bedrock into a vast system of interconnected fractures and fissures, creating the great mountain ranges of the world. Roughly 80% of the world's precipitation occurs at higher elevations. Conventional hydrologic theory maintains that most of this water evaporates, while the remainder flows down the surface and shallow subsurface into streams, lakes, or alluvial aquifers, and that no appreciable amount of water penetrates the impervious bedrock. According to the mega watershed paradigm, water which falls as rain and snow in the higher altitudes of the mountain ranges is not all lost to runoff and evaporation, but rather much of it enters into and moves through the fractures and fissures of the shattered bedrock, creating a massive interconnected system of fractures filled with enormous volumes of renewable fresh water. This is the mega watershed.
The concept of the mega watershed is understanding that instead of figuring out what topographic area feeds an aquifer a few hundred feet underground, think about what geographic area feeds an aquifer that might be 1,000 or 2,000 feet below the ground. And when you start thinking that way, you realize you're looking at this just vast area.
As more water enters the fracture system, it is forced downhill by gravity and eventually is released into the deep ocean. These discharges of fresh water are at rates as high as hundreds of millions of gallons per day, a natural renewable resource forever lost to human use, until now.
Now there are questions about, well, why didn't we know about this water? And The problem is that the measurement of precipitation at these high altitude areas, the higher mountains, is one of the most uncertain measurements we make. Precipitation that falls into gauges on high mountains is under measured by about 80% because of snow blowing out of the gauges. On average, we vastly underestimate how much rainfall falls in the high altitudes. So there is a lot of water there that we can access, and it is quite sustainable.
EarthWater Global brings state-of-the-art satellite imagery, on-site surveillance, and decades of experience to the science of finding water.
At NASA, I spent most of my time designing and thinking about how to study water from space. EarthWater Global has an innovative way of looking at the groundwater system that is not traditional to hydrological sciences.
The oceanic plate with the South American plate.
Using petroleum geology exploration ideas and tools, looking at fractures and faults in the hard rock, they've discovered that there are in fact huge conveyances, huge transmission lines for water, and knowing that allows EarthWater Global to pinpoint where those geologic structures are, and almost like you would look for oil, you can now look for water in these deep fracture zones.
So this is very different than large conventional point source solutions, for instance a dam or desalination plant, where all the water is at one place and the demand is spread out. Those are huge infrastructure requirements. We're actually understanding, in collaboration with typically the water ministry, where the water is needed, and then siting our wells in or around those areas. That's totally unique within the water industry.
In 1999, EarthWater Global turned their attention to the Caribbean island of Tobago, where the government was in crisis, only able to meet 65% of the water demand. Tobago considered building a dam here, in the oldest protected rainforest in the Western Hemisphere.
If we were to build a dam, then we would have covered over a significant acreage of natural, pristine environment, which is a famous attraction for tourists who come to the island.
Despite the lush environs, surface water in Tobago is often unreliable, scarce in the dry season, and otherwise expensive to treat. Within a year, EarthWater discovered mega watershed resources capable of sustainably producing 50 million gallons per day, 10 times the supply of the proposed dam, and 100 times previous groundwater estimates.
Because they were able to drill a well within a 2-mile radius of the hotel, it meant that the water was found close to where it was needed, which is one of the main advantages of using this technology, where you can actually more or less get water where you want it.
It's delivered every day the same way. Potable water quality doesn't change with season, it doesn't change with big rainfall, hurricanes, or anything else.
In the future, EarthWater Global believes that with the mega watershed paradigm, they can develop up to 100 times more groundwater than is currently thought available in many regions of the world.
Nations and communities of people that are terribly short of water don't need to be short of water if we use a new perspective in finding that water.
The provision of potable water can have a profoundly positive impact on health, the environment, and economic development.
It's very exciting, and we're starting to see that around the world with our customer partners in the government sphere, that they really understand that we are unique.
EarthWater Global has the proven capacity to discover and develop mega watershed water on a large scale, on budget, on time, and to deliver this renewable supply of water to people who really need it where they need it.